Good morning, everyone. As you know, I told you yesterday that I won't be here today. We're going to review the questions again as far as the criteria for success for each question. So question number 1 of the lab. You have learned that acceleration is defined as an increase in speed, a decrease in speed, or a change in direction. Using your data that you have here for A1 and A2, make sure that you talk about that in your explanation. Secondly, make sure to go back to the ramp setup, and look at that for whether or not there was any change in direction from distance A to distance B. Now that we understand that, you should explain whether there was a different acceleration across distance A and B, whether they're the same or different using your data from this chart. Question 2. Question 2 and question 3 in your chart are just plug and chug acceleration. Just a reminder that for number 2, this first data here is the initial velocity, and this value here is the final velocity. Similar here is initial and final. Okay, make sure you include your units. Number 4 starts off with a large amount of graphs and information. That information is there to help you answer question 2. Now remember, question 4. Question 4, it is talking about velocity. Do not talk about acceleration. Be very careful when you do so that you talk about whether or not you have positive or negative velocity. Explain using the data from your charts up here. Next, question 5. Acceleration can be graphed in another way using a velocity time graph. It shows the changing velocity of a sprinter. This person is the first runner that we're talking about, but then they ask you to assume another sprinter is running the same race, and they get to a top velocity of 9 meters per second by 4 seconds. My best suggestion to you would be to sketch this second runner on your graph and then discuss below. Number 6, create a velocity time graph by plotting the data in the table below. Remember that you need a title, you need your axes labeled with units, you'll see those above in the chart, and you need to have it as a line graph, not a bar graph. It is a line graph because time is the bottom axis. Finally, number 7, draw a line, the first one is position time, of the marble rolling down the ramp. And the second piece is using what you know about acceleration and your data above, sketch a chart of how the velocity is changing over time as it rolls down that ramp. You may want to go back to your notes, especially about this velocity versus time graph. Next, in the graphs below, draw a line that represents the marble rolling across the floor. Again, you're going to be doing position versus time and a velocity versus time. Use your notes and perhaps the charts that you see here for question 4 to help you solve this problem. These are sketches. You don't need values. They should just be the correct shape. That is the end of this lab.